Hello, this is Professor Chevan Acharya again. In this video, I will do the homework from section 5.3. The 5.3 about independence and the multiplication rule. That's the topics. Question number 1. This is the definition questions. Fill in the blank, and there's a definition, and you have to select one of the word from the list of the given words. And the independent, disjoint, unusual, and dependent. You have to pick one of those to fill in the blank. Uh, and two event E and F are blank if the occurrence of the event E in the probability experiment does not affect the probability of event F. If occurrence of event E does not affect the probability of event F, they are called independent. Therefore, you pick independent here. Question number 2. The word or in the probability implies we use the addition rule. Okay. Therefore, if you have a or, we use addition rule. And just quick note that if you have and, we use multiplication rule. That's what we're going to do in this section. This is 5.3. And if you have or, we use addition rule. That's the 5.2 in the previous section. Question number 3. There is 3 part of the questions. Determine the event E and F are independent or dependent. That's the question, and justify the answer. The first part of the question is a person having an at fault accident is event E. F is the same person being prone to the road race. Okay, pause the video and ask yourself, as are these two events are independent or dependent? What do you think? Yes, they are dependent. Answer is C. And what's the explanation? Because being prone to the road race can affect the probability of a person having an at fault accident. Therefore, these two events are obviously dependent. Part B. E is a randomly selected person at a school A having a high GPA. F is the randomly selected person at a school B having low GPA. Obviously, E cannot affect F in this case, or F cannot affect E, because the people were randomly selected, so events are independent. The answer is C again. Therefore, you can select the C, which says E cannot affect F, and vice versa, because the people were randomly selected, so the event were independent. And part C, the rapid spread of coca plant disease, and part F, the price of chocolate. And C is the answer here. And notice that the chocolate is made up from coca plant. I mean, they use a coca plant to make a chocolate. Therefore, rapid spread of the coca plant disease affect the price of the chocolate. Therefore, answer for this question is C, that dependent. Question number 4. Determine if the following statements are true or false. The two events are disjoint, they are also independent. That is obviously false. In other words, disjoint event can never be independent. Can never. Therefore, if two events are disjoint, they are not independent. That's the false statement. Question number 5. Suppose E and F are independent. Notice that E and F are independent. And what is P, E and F? Pretty much here we're looking for probability of E and F. And since E and F are independent, the probability of E and F equals to probability of E times probability of F. As I mentioned before, and is multiplication. Okay, therefore if you multiply probability of E and probability of F, you will get probability of E and F when they are independent. And now you're looking for this, and you have a value for probability of E, which is 0.3, times probability of F, which is 0.9, and you multiply, you get 0.27. That's the answer. Question number 6. What is the probability of obtaining 3 head in a row? Listen, 3 head in a row. When flipping a coin, and interpret the probability. And looking for the probability of 3 head in a row. And here looking for probability of 3 head in a row. Okay. To get all 3 head in a row, first must have a head, and second must have a head, and third must have a head, because you want 3 head in a row. In other words, you have first head and second head and third head. Okay, and notice that getting first head is independent to getting second head. And in other words, the probability of occurrence of first head does not affect the probability of occurrence of second head, and so on, doesn't affect the probability of occurrence of third head. Therefore, in other words, these 3 events are independent. Okay, therefore we multiply all these 3 probability. What's the probability of first head? Half. What's the probability of getting second head? Half. The probability of getting third is half. In other words, you can put 0.5 to the power 3, or you can do half to the power 3, whatever you like, and use a calculator to find the value. Let me do that for you. Or you do 0.5 to the power 3, and you get 0.125. The answer is going to be 0.125. And in the box you type 0.125, and you round it to 5 decimal places, and that's okay. If you want, you can put 2 more 0 if you like, but you don't have to do that. That's the acceptable answer, 0.125. Next part of the question. Consider the event of coin being flipped 3 times. Okay. In other words, this is the one event. It's the one event. That's what the question says. It's the one event. See, consider the event of a coin being flipped 3 times. If the event is repeated 10,000 different times, notice that if you repeat this 10,000 different times, and what do you expect? All 3 head in a row. That's the question. To find that, you multiply 0.125 times 10,000. Okay, that gives you 1250. In other words, if you flip a coin 3 times in a row, and if you do that 10,000 different times, and you will get 1250 times you get all 3 head in a row. Okay, before I do question number 7, I want to do this question number 11, okay, and come back to question number 7. And here is the question. Explain how the complement can be used to find the probability of getting at least one item of a particular group. And here we're looking for probability of at least one. Okay, and probability of at least one item. That's I'm looking for, at least one item. Whatever item is going to be, is going to be 1 minus probability of non-item. Okay, that's the formula. That's what we're going to use in this section. This formula going to use much of the time in this section. Probability of at least one of any item, whatever item is that going to be, is 1 minus probability of none. And you can say probability of at least one equals 1 minus probability of none. That's what you said. Therefore, in these questions, the answer for question number 11 going to be D. The complement at least one is none. Notice that the complement of at least one is none. Therefore, you do probability of at least one equals to 1 minus probability of none. Notice that at least one of any item or any event equals 1 minus probability of non-event or item. Okay, let's go back to the previous question, number 7. Okay, because in the 7 we're using the probability of at least one of whatever item is there. Let me erase this and write it down. Question number 7 here. In a certain country, the true probability of a baby being a boy is 0.538. Notice that 0.538 is probability of baby being a boy. Okay, in other words, you can say that the probability of the baby gonna be boys equals to 0.538. Again, another word, around 53.8% chance that the baby is gonna be a boy. Okay, that's the first part of the problem. Among the next 6 randomly selected births. Now, if you select 6 births at random, okay, what is the probability that at least one of them is a girl? Listen, that's what I'm looking for. What's the probability that at least one of them is a girl? Here we're looking for probability of at least one girl. Okay, be careful. This at least one out of 6, those are selected, is going to be a girl. And as you remember that we talk about probability of at least one of particular event going to be 1 minus probability of none of the event. Therefore, whatever you put here girl, you put here girl. Therefore, in this case, you put 1 minus probability of non girl. Notice that non-girl means what? None of those out of 6 going to be a girl. And what do you mean by none of them are girl? None of them are girl means what? All 6 are what? All are boys. Right? Because none of them out of 6 are girl means what? All are boys. All those selected 6 are boys. Okay? Therefore, I should write this way. 1 minus probability of all boys. And what's the probability of being one boys? 0.538. Where how many boys are selected? How many kids are selected? You select 6 birth. I mean, not kids, 6 birth. And the probability of being all 6 boys going to be 1 minus 0.538 to the power 6. We're using independent event formula because this occurrence of first boy doesn't affect the occurrence of second boy and third boy and fourth boy and so on. Therefore, you multiply this 0.538 probability 6 times to get the probability of all boys. And here the probability of all boys is going to be this. Okay, listen, probability of all boys, I mean all 6 boys pretty much, going to be 0.538 to the power 6. I use the calculator. Let's do that for you. 1 minus 0.538 to the power 6. Use this TI calculator, equals to 0.9757, and instruction says round it to 3 decimal places as needed. Therefore your answer is going to be 0.976. okay, the answer is going to be 0.976. okay. Question number 8. According to the Internal Revenue Service record, 1.88% of the household tax return are audited. Therefore, the chance of you are being audited is going to be 0.0188. Therefore, probability of audited equals to 0.0188. okay. According to the Humane Society, 28% of the household own the dog. Therefore, probability of the person who own the dog equals to 0.28. In other words, 28% own the dog. Therefore, the probability of randomly selected person who own the dog is 0.28. okay, these two are number given. okay, assuming dog ownership and the audit are independent. Notice that here there's two events: dog ownership, audited, two independent event. You assume that owning dog doesn't affect the probability of chance of auditing. okay, and what is the probability that a randomly selected household is audited and own the dog? Listen, you see that obviously you're looking for audited and on the dog. Look at in the middle, and okay, here you're looking for probability of audited and own a dog. And notice that these are independent event. The question says obviously they are independent. Think about that, because probability of occurrence of one event does not affect the probability of other event. Therefore, if you're independent and if you have and, you multiply. Therefore, you basically multiply 0.0188 and 0.28. 0.28. If you multiply this to this is 0.28. okay, you multiply this two, because these two events are independent, you get the answer, whatever, rounded to 6 decimal places as needed. The instructions say rounded to 6 decimal places, and the answer must be 0.005264. okay, that's the answer, 0.005264. 1 2 3 4 5 6 decimal places. Question number 9 is similar to question number 8, therefore I'm not going to do that. Just want to read for you. Here, find the probability of tossing a head and then rolling a number greater than 5. Here we're looking for probability of tossing head and rolling 5. That's why you look. Oh, I'm sorry. It's rolling greater than 5. Okay, rolling number greater than 5. And what's the probability of tossing head? 1/2. 1/2 times what's the probability of rolling greater than 5? 3/8, because there is a 3 number, technically 6 7 8, which are greater than 5 over 8. There is 8 number in total, and you multiply this to 3 times 1 3 over 2 times 8 16, and if you divide 3 by 16 using calculator, your answer is going to be here and rounded to 3 decimal places. Question number 10. Suppose Dan wins 37% of all bingo game. In other words, the probability of Dan wins bingo game is going to be 0.37. Okay, what do you think probability that he gonna lose the bingo game? 1 minus 0.37 is the complement. Lose is complement of win, is gonna be 0.63. Okay, the question number 1. Find the probability that Dan wins 2 bingo game in a row. Probability that wins 2 bingo game in a row. To win 2 bingo game in a row, he has to win first game and second game. Therefore, you have to multiply this probability 0.37 twice, or 0.37 to the power 2. That gives you 0.1369. If you round it to 4 decimal places, that's the answer for the first question. That is the probability that Dan wins 2 bingo game in a row. In other words, 0.37 squared is same as 0.37 times 0.37. Since winning first game is independent to the second game, okay, therefore you have to multiply this twice because of independent rules. And next question is, find the probability that Dan wins 4 bingo game in a row rather than 2. You have 4 here. Same idea here. 0.37 to the power 4 is going to be 0.0187 when you round it to 4 decimal places. Use a calculator, find 0.37 to the power 4, because we want a probability that Dan wins 4 bingo game in a row. Okay. Part C. What's the probability that Dan wins 4 bingo game in a row but does not win 5 in a row? That means we're looking for probability that win 4 game in a row and lose 5th. That's what we're looking for. Notice that we have an and here. And you know what's the probability of the win 4 game in a row? What's the probability of he win 4 game in a row? We did in part B, which is going to be 0.0187 times. What's the probability that Dan loses 5th game? Here you go. The probability that Dan loses 5th game is going to be 0.63. Okay. If you multiply this two, you get 0.0118. That's the answer for part C. I did question number 11 before. Let's do question number 12. About 18% of the population of the large country is allergic to pollen. If the first sentence says probability that person allergic to pollen, let's write ALERGIC, allergic to pollen. The probability is going to be 0.18 because 18% has a allergy to pollen. And part A is, if 2 people are randomly selected, what is the probability that both are allergic to pollen? Let's do the first part here. For part A, you select 2 people and you're looking for a probability of both allergic to pollen. In other words, to find the probability that both allergic to pollen, you multiply 0.18 twice, or to the power second, because the first person either being allergic to pollen or not doesn't affect the second person being allergic to pollen. Therefore they are independent. Therefore you multiply and round the decimal to 4 decimal places. your answer must be 0.0324. Okay, that's part A. Part B, what's the probability that at least one allergic to pollen? Let me do this part B here. uh, B is probability of at least one allergic to pollen. That's what I'm looking for, right? Allergic to pollen. And this is same as 1 minus probability of non-allergic to pollen. Okay, non-allergic to pollen. Again, remember that at least one of item probability is less 1 minus probability of none of the item. Okay, again, probability of at least one going to be 1 minus probability of none. And here the item is allergic to pollen. That's what I'm looking for. What's the probability of at least one allergic to pollen? And the formula is 1 minus probability of non-allergic to pollen. What do you mean by non-allergic to pollen? Out of 2, none of them has allergy to pollen. And what's the probability of non-allergic to pollen? 0.82 to the power 2. Why? Because remember that 18% has allergy to pollen. In other words, 82% has not allergic to pollen. Remember that there's 2%, both are not allergic to pollen. And the chance of not allergic to pollen is 0.82. If you multiply 0.82 to the power 2, and if you use a calculator, 1 minus, let me just put it here, 1 minus 0.8 to the power 2, you get 0.3276, rounded to 4 decimal places. That's the answer, 0.3276. Question number 13. Okay, question number 13 is similar to question number 12, and I just want to do real quick here. There is 2 probability here. One is 99.2%, another is 0.08%. And the one is the probability that the test come back to negative, and other is probability that test come back to positive. And the probability that the test come back to positive is going to be 0.008 over here, and the probability that the test come back to negative going to be 0.992. Remember that 992% the test come back to negative. Therefore 99.2% as a probability is 0.992. You notice that if you add this to 0.008 and 0.992, this add up to 1 because they are complement of each other. Okay, that's the given. And your first part of the question is they are looking for if there is test is done for 7 people, and what's the probability that all 7 tests are negative? Therefore I'm looking for probability of all 7 are negative. And what you're doing here is probability that you get the test negative is 0.992, and if you're looking for all 7 tests negative, the chance of getting all 7 tests negative is 0.992 to the power 7, and you round it to 4 decimal places, and that gives you 0.9453. Okay, part B, at least one positive. You're looking for at least one test positive. Out of 7, what's the probability of that at least one positive. And by the formula, it's going to be 1 minus probability of non-positive. Again, we refer to the question number 11. The probability of at least one of the item is 1 minus probability of none of the item. Therefore, the probability of at least one positive is same as 1 minus probability of non-positive. Okay? And non-positive is same as all 7 negative. Okay, remember that non-positive means all 7 negative. Alright? Therefore, what you're going to do is all 7 negative. What's the probability of all 7 negative? We found in previous spot is going to be 0.9453. You mean the 1 minus 0.9453. You subtract from 1, you get the answer 0.0547. That's the answer for part B. Now, question number 14 is similar to the previous one. Therefore, I'm not going to do question number 14. Let's do question number 15. Among 26 to 31 years old, 27% says that they have operated heavy machinery while under influence of alcohol. Okay, now that means 27% operated machine under influence of alcohol. Suppose that 26 to 31 years old are selected random and find the following probability here, A, B, C, D. Okay, how many selected? 5. And probability of who operated under influence of alcohol operated equals to 0.27. Notice that I just put operated here. In other words, this is just operated under influence of alcohol. Okay, I didn't write all the word here. Here operated means those operated under influence of alcohol. And what is the probability that the who do not operate under influence of alcohol? Not operated. Let's write down that way. Not operated equals to 1 minus 0.27 is going to be 0.73. Okay, in other words, 73% do not operated under influence of alcohol, 27% operated under influence of alcohol. Alright, let's answer part A. Part A. What's the probability that all 5, remember the 5 people are randomly selected, have operated under influence of alcohol? That means you have to do 0.27 to the power 5 for part A, and you multiply 0.275 times, you raise the power 5 for 0.27 using calculator, you get 0.0014. When you round it to 4 decimal places, the answer is going to be 0.0014. Part B. Remember, the part B has at least one probability. For part B, you're looking for probability that at least one has not operated. Okay, what's the probability that at least one has not operated? At least one has not operated. What's the formula? At least one is going to be 1 minus probability of none has not operated. Notice that at least one has not operated means none has not operated. You guys remember that from the question number 11? At least one has not operated equals to 1 minus probability of none has not operated. Okay, what do you mean by probability of none has not operated? Let me continue here. It's going to be 1 minus probability of none has not operated under influence of alcohol means all has operated. All has operated under influence of alcohol. That means all 5 has operated under influence of alcohol. Okay, and what's the probability of this? What's the probability of this? We found in part A, which is going to be 1 minus 0.0014, and your answer is going to be 0.9986. Part C, what's the probability that none of the 5 have operated? None of the 5 have operated means what? All 5 has not operated, right? All 5 has not operated. All 5 has not operated. And notice that the probability of not operated is 0.73. Therefore, for this one, we find the probability multiplied 0.73 5 times, and that gives you 0.2073, rounded to 4 decimal places. Okay, and let's do the part D, the last part of this question. Part D says, what's the probability that at least one, again, at least one has operated? Okay, at least one has operated. That means 1 minus probability of none has operated. None has operated. Okay, again, as you know from question number 11, at least one has operated is same as probability of none has operated. Okay, what's the probability of none has operated? Under influence of alcohol, we found in part C, none of the 5 have operated. From part C is going to be 1 minus 0.2073. That gives you 0.9727. Okay, that's the answer for part C. Question number 16. For parallel structure of identical component, the system can succeed if at least one of the components succeed. At least one of the components succeed. Assume that the component fails independently for each other, and that each component has 0.18 probability of failure. Here, probability of failure of the component is going to be 0.18. What's the probability of succeed then? Let's say success is going to be 1 minus 0.18. That gives you 0.82. Okay, just if you need it. Okay, would it be unusual to observe both components fail? Sorry, one component fail, not the both. First question, would it be unusual to observe one component fail and the next part is two component? Okay, listen, for one component fail, what's the probability of the one component fail? 0.818. Therefore it would not, because less than 5% is unusual, but this is not less than 5%. You would not be unusual to observe the component fail. One component fail. Since the probability of that one component fell, what is that? 0.18 is greater than 0.05. Okay, but how about the two component fell? The probability of two component fell, let's say 2 fell, gonna be 0.18 to the power 2, because you multiply 0.18 twice, and this gives you 0.0324. Since you have to round it to, it's a do not round, therefore you just write all the decimal points. Okay, and for two component fail, it is it would be unusual because the probability is less than 0.05. Therefore, for two component, it would be unusual to observe two component fails, since the probability that two component fell was that 0.0324 is less than 0.05. Okay, that's the first part of the question. For part B, what's the probability that the parallel structure with two identical components will succeed? Okay, to succeed, notice that for parallel structure with two identical component, the system can succeed if at least one of the components succeed. Therefore, you go looking for the probability that at least one succeed. For part B, probability of at least one succeed equals to 1 minus probability of non-succeed, right? Because by same argument, probability of at least one going to be probability of none. Notice that probability of at least one of the item is 1 minus probability of none of the item. None of the succeed means what? Both fail, right? None of those two succeed going to be both fail. What's the probability of both component fail? 0.0324. Therefore, here you do 1 minus 0.0324, you get 0.9676. Okay, and here you put 0.9676. Here round it to 4 decimal places. 4 decimal places, and that's the 4 decimal. Question number 7. The probability that certain state will hit by the tornado in any single year is 1/5. Here 1/5 is probability of hit by the tornado in any single year. I should say probability of hit equals 1/5. What's the probability of will not hit? Any single year is going to be 1 minus 1/5, which is going to be 4/5. Okay, remember that's the complement. Therefore, the probability of hit is 1/5. Again, hit by tornado, major tornado in single year, and probability of that tornado does not hit in the single year is 4/5. Okay, for part A, what's the probability that the state will hit by the tornado in 2 years in a row? 2 years in a row. In other words, the probability we got to looking for is the tornado will hit in 2 years, next year and next year, 2 years in a row. Therefore, for part A, you're looking for 1/5 to the power 2. Okay, and here you round it to 5 decimal places. You divide 1 over 5 and raise the power 2. Or you can just use 1 over 50 to the power 2 like that in the calculator. Let me show you. Parenthesis 1 divided by 5 raised to the power 2. You get 0.04. Okay, round it to 5 decimal places, but it doesn't matter if you put 0.04 or you can put 0.04000. Is the same thing. No worry about 0 in the back. Okay, that's the first part. For B, what is the probability that this will hit by the major tornado in 3 consecutive years? Here, similar to part A, it's a 2 year in a row. Here, 3 year in a row, because 3 consecutive year and hit by the major tornado. Okay, and similar idea, you do 1 over 5 to the power 3 and use a calculator like we did before. Your answer is going to be 0.008. For part C, we're looking for the probability that this will not hit in next 10 years. Notice that, will not hit next 10 years. The probability the the tornado does not hit is 4/5. In other words, there is 4/5 probability that the tornado will not hit. Okay, therefore for the part C, you're looking for 4/5 to the power 10, because you're looking for will not hit next 10 years, means next year, up to 10 years will not hit. Therefore you multiply 4/5 10 times and do the calculator, 4/5 to the power 10, and round it to 3 decimal places, and you'll get 0.107. okay, 0.107. Finally, part D says find the probability that the state will hit by a major tornado at least once in next 10 years. And here looking for probability at least in next 10 years. Okay, hit, I says a hit at least in next 10 years. I says a hit at least in next 10 years. This sum is 1 minus per non-hit in next 10 years. I means none of the tornado hit in next 10 years. That means none of the tornado hit next 10 years. That means none hit in next 10 years. What's the probability that none hit next 10 years? What this number equals to? What is the probability that none hit next 10 years? We just find that in part C, which is going to be 1 minus 0.107, and if you subtract, you get 0.893. That's the answer for part D of this question number 17. Okay, 18 is the last question of this homework, and this is similar to previous question. I'm not going to do that. I hope you're going to finish yourself. That's all about the homework from this section 5.3. I hope this helps you to do the homework in MyLab Math. Good luck.